Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Uh, in the previous discussion, we studied the hypothesis testing procedure for a population mean when population standard deviation was known. So in that case, we used Z formula or Z statistic, and we solved several questions from that section. So now we are familiar with the concept of not only Z distribution, but we also know that how we would take help of Z statistic in different situations wherever it is required. The next topic is hypothesis testing for a population mean. When population standard deviation sigma is unknown. Normally, from our past experience, we know that what is the population standard deviation sigma, but in many cases, we are unaware of the value that is for sigma, population standard deviation. So in those situations, we take help of sample standard deviation that is denoted by S. So we say that this is the sample standard deviation, but this is the best estimate for the population standard deviation. So we may use this. So as we use S instead of sigma, we use T statistic instead of Z statistic. So this is the formula that is known as T statistic formula. X bar minus mu divided by S divided by square root n. So you are familiar with almost all terms. X bar is sample mean, mu is population mean, S denotes sample standard deviation, n is sample size, and T is for test statistic, that is known as T statistic. So let us solve a few examples from this section. Basically, this is the section in your book. So you may solve or you may see these two examples that are solved in your book. So we shall try to solve some questions from the exercises. So this is the first example that is there in your book, and you may solve it on your own. I suggest you to solve it on your own, and if you feel any problem, you may ask me later on. So I want to solve a few questions from the exercise so that you become able to solve the questions that are there in the exercises. This is self-review. When I would solve some questions from the exercise, you would be able to solve this question yourself. Okay, so let us solve question number 11 of your book. The Rocky Mountain District sales manager of Roth Publishing Incorporation, a college textbook publishing company, claims that the sales representatives make an average of 40 sales calls per week on professors. Several reps mean representatives, say that uh, this estimate is too low. To investigate a random sample of 28 sales representatives reveals that the mean number of calls made last week was 42. The standard deviation of the sample is 2.1 calls. Using the zero point 0.05 significance level, can we conclude that the mean number of calls per salesperson per week is more than 40? Okay, so you have to answer this question. Can we conclude that the mean number of calls per salesperson per week is more than 40? Okay, so how would you start solving this question? First of all, you will write down uh, step one, or first of all, you may write down solution, then come over here. Step one. What is step one? Null and alternate. Step one, null and alternate hypothesis. So what are these two hypotheses? First of all, you will write down mu h naught mu h1 mu. So you have to construct the null and alternate hypothesis. How would you construct it? You will read the question again. Sales representatives make an average of 40 sales per week on professors. Several representatives say that this estimate is too low. To investigate a random sample of 28 sales representatives reveal that the mean number of, so you can see, a random sample of 28 sales representatives. So these 28 that are in our account are revealing that the mean number of calls made last week was 42. It means this 42 is X bar. This value is X bar, not mu. Mu is basically this 40. Okay. So you will write down mu is equal to 40 here, 40, and here again 40. Okay, but now you have to decide that which sign will be there, equality sign or less than or equal to more than. So for that you have to see the standard deviation of sample is 2.1 calls. Okay, so this is S. So it means that you have to use T statistic. Can we conclude that the mean number of calls per salesperson per week is more than 40? So this more, the word more is helping you in writing down the alternate hypothesis. So you will put this sign over here, more than 40. So now the other two possibilities are less than or equal to. So less than and equal to will be there in the null hypothesis. So in this way, you will construct the null and alternate hypothesis. Fine. Then comes step two. Step two. What is step two? Step two is level of significance. And level of significance is also given. It is 0.05. So you will write down alpha is equal to point 0.05. Then there comes step three. Which is test statistic. So what is your test statistic in this case? As you see, sample standard deviation is given, population standard deviation is unknown. So you will use t statistic, and the formula is this: t is equal to x bar minus mu divided by s divided by square root n. So you will write down this formula over here in this step. T equals x bar minus mu divided by S divided by square root n. This is the formula. So you will leave this step on this point, and then you will write down step 4. What is step 4? Step 4 is decision rule. So in decision rule, you will draw the distribution. So definitely this is the normal distribution. So you will draw the normal distribution, and then you will see that beyond which point you would reject the null hypothesis and where you would remain unable to reject the null hypothesis. So first of all, you will draw the distribution. So you may draw the distribution in this way. And then there will be another scale. Let me draw the other scale, that is z scale. This is your z scale, and in this case, this is your x bar. So in the center, there is mu. The value for mu is given, that is 40. And definitely against mu, the value of z will be 0. Okay. So now you have to decide that whether the hypothesis is single-tailed or two-tailed. So it is one tail or single tail, and tail is to the right side of the distribution, because this kink is an indication that it would be right-tailed. So you will draw a tail to the right side of the distribution. Let us put this tail over here. Right side is this. You will draw this line over here. This is one tail. And here you will write down the level of significance. The level of significance alpha is equal to 0.05. This is your level of significance. So now you are interested in finding out. Sorry, this is not z scale. This is t scale, because we don't have the population standard deviation. So this is t scale. So you would have to write down here t, not z. This is t scale. Okay, so now what will be the value for t over here? The critical value of t. Definitely the critical value you will find out from the t distribution table. And how will you find it out? This is single tail. Come over here. This is the t table. And in t table, you have to see one tail. This is one tail. And the level of significance is 0.05. The other important thing that you have to see is degree of freedom. So degree of freedom is equal to n minus 1, sample size minus 1. So you have to see that what was the sample size in this case. How many? 28 sales representative. Sample of 28 sales representatives. So 28 is your sample size. So degree of freedom will be 28 minus 1. So the answer is 27. So you will see this table and you will see that where is 27. So 27 is this value. Fine. So you will move rightward and then you will move. So this is basically the column. So against 27, this is the value. 1.703. 1.703 is the value. That is against 0.05 level of significance. So you will write down this value 1.703. 1.703 over here. 1.703. This is the value. So this is the critical value. This is the critical value, or you may call this t tabulated value. So now you will say, you will write down in this step that if, so this is the rejection region beyond this point rightward. This is the rejection region, and this whole region is the region where you will remain unable to reject H naught, or you may call this as an exception region. Okay. So here you will write down a statement like this: if the calculated value of t statistic will exceed 1.703, we would reject H naught. So in this way, you will write down statement in the fourth step. Then you will come to the fifth step. You write down here fifth step, or step 5. What is this step? This step is computations. So here you will substitute the values in the formula that you have written in the third step. So let us substitute the values over here. First of all, you will again write the formula. T is equal to x bar minus mu divided by s divided by square root n. So what is x bar? X bar is 42. X bar is 42. Write down 42 over here. And what is mu? Mu was 40. You must have your calculator with you because you have to solve it. I don't have any solution for this question. So what is S? S was, what was S? Sample standard deviation. The standard deviation of the sample is 2.1 calls. So 2.1 is your sample standard deviation. Substitute this value over here. 2.1 divided by square root 28. 28 was the sample size. So if you have calculator with you, please give me the answer.
5.0395. 0395.
5.0395, or you may write it down as 5.04. Right. So this is your calculated value for t statistic. This is t calculated. So now you may compare this value with the tabulated value. Okay, so you write down here 5.04, and what was the tabulated value? It was 1.703, if I remember. So now you may see that which value is larger out of these two. This is t, this is t calculated, and this is t tabulated. So this value is greater. So we have already said that if our calculated value will exceed this value, we would reject H naught. So in this case, you would reject H naught. So here you will write down reject H naught. Fine. Then there comes step 6. Come over here, write down step 6, interpretation. Interpretation. So how will you interpret the result? You will again come to the question and you will see what is the story over there. Basically, you have rejected the null hypothesis. This we have rejected. It means you have accepted the alternate hypothesis. The exception of alternate hypothesis suggests what? Can we conclude that the mean number of calls per salesperson per week is more than 40? So you will say yes. You will write down this statement or you will replicate this statement over there. Yes, as we have rejected the null hypothesis, it means the number of calls per salesperson per week is more than 40. So you may write down this statement over here as we have rejected the null hypothesis, so we can conclude that the mean number of calls per sales person per week is more than 40. So in this way, you will solve the question. Then there comes question number 12 and question number 13, 14. So we may solve a few more questions quickly. Let us solve question number 12. So here there is some trick in solving question number 12. Let us see how will we solve this question. The management of White Industries is considering a new method of assembling its golf cart. The present method requires a mean time of 42.3 minutes to assemble a cart. The mean assembly time for a random sample of 24 cards, so this is the sample size, using the new method was 40.6 minutes. Okay, so it means the time has reduced. The time has reduced, and definitely for assembling the cart. And the standard deviation of the sample was 2.7 minutes. So this is S. Using 0.10 level of significance, can we conclude that the assembly time using the new method is faster? So now you would write down the null and alternate hypothesis first, and let us see how will we construct the null and alternate hypotheses. Step 1, definitely you will write down solution. Then step 1, null and alternate hypothesis. So what will be the null hypothesis? What will be the alternate hypothesis? So let us construct H naught, H naught, and H1. As I have already suggested you to write down the alternate hypothesis first. So you will write down the alternate hypothesis first. How will you write it? We are talking about average, mean, population mean. So mu will be there. Mu will be there. Fine. So then you will write down the average, population average or population mean that is given. The present method requires a mean time of 42.3. This is the population mean. So basically we know this information. as he's saying that present method requires this as mean or average minutes to assemble a card. So this we know from our experience. So our past experience, based on our past experience, we know that assembling a card takes 42.3 minutes. So this is the population mean. Okay, so 42.3 will be written over here. 42.3 will be written over here. Fine, but we which sign we will put for alternate hypothesis and which for the null hypothesis, this we have to decide first. This is very important. Otherwise, if you put the wrong sign over here, then the result will be incorrect. So now see, 40.6 minutes using the new method. 40.6 minutes are required to assemble a card. So if you see, 40.6 is less than 42.3. Okay, so time has reduced, although the word faster is there, but the time has reduced. The situation is different basically. The situation is this, that as time decreases for assembling a card, it means the efficiency has increased. It means the new method, whatever method they are going to introduce for assembly, that is basically taking less time for assembling the card. To assemble a card, less time is now required based on the sample information. So 40.6 is less than 42.3. Therefore, this less than sign you will put over here. Okay. So in the null hypothesis, the remaining two signs will be there. It means greater than or equal to, greater than or equal to, and in this case, less than. So we have found this information from this statement. Using new method was the mean assembly time for a random sample of 24 cards. Using the new method was 40.6 minutes. So 40.6 minutes is less than 42.3. It means less time is now required to assemble the cards. So therefore, this sign will be there. So if you are going to reject the null hypothesis, definitely you will be accepting the alternate hypothesis, and acceptance of alternate hypothesis will mean that yes, the assembly time using the new method is faster. Okay, so this faster is also there, is there, but there will be the sign that will be less than. So less than will mean that faster, less time will mean faster. So therefore, you will construct the null and alternate hypothesis in this way. So this is a tricky question, but you have to recognize this fact from the given story. So now there is step 2, and in step 2 you will write down, sorry, the level of significance. This is your step 2. Level of significance, it is given. It is 0.10, 10%. So you write down over here, alpha is equal to 0.10. Then comes step 3. Step 3, and that is test statistic. So test statistic is again same, you know, t is equal to x bar minus mu divided by sy, because sample standard deviation is given and population standard deviation is unknown. So you will write down the formula over here, t is equal to x bar minus mu divided by s divided by square root, and simply you write down this test statistic over here, and then you will move to step 4. What is step 4? Step 4 is decision rule. Here you will draw the distribution. So definitely t distribution. So let us draw this distribution. This is the distribution. This is your x bar scale. This is your t scale. Okay. So in the center, there is mean, and that value is 42.3. And against this value, the t value is 0. Now you have to see that to which side you will put the tail of the distribution. So this is, as this is single tail and tail is to the left side, so you will draw a line to the left side of the distribution like this. Fine. So this is 0.10 single tail. So what will be the critical value? So definitely you will use the table for against this value. This is single tail. So you will come over here. First of all, you will decide that what is the degree of freedom. So in this particular case, if you see random sample of 24 cards, it means n is 24 and degree of freedom will be n minus 1, so 23. So 23 is the degree of freedom and level of significance is 0.10. This is single tail. So you will come in this table, one tail or single tail, and come down 23. Where is 23? This is 23. And what is the level of significance? 0.10. So you will come down. Where is 23? This value will be written 1.319. 1.319 is the critical value. 1.319. 1.319. So here you will write down a statement that when you will reject the null hypothesis in the decision rule. So let us write down that statement. So you will write down over here, if definitely this will be with negative signs. Remember, this will be with negative sign because it is to the left side of the distribution. So here you will write down if uh, the calculated value of t-statistic will be less than minus 1.319, we would reject H naught. So you can see from this, so you can see values will be like this, 0, -1, -2, -3, -4, up to minus infinity. So if some value is like this, let's say -2 is there as calculated value. So -2 will be to the left side of this value. -3 will be to the left side of this particular value. And if you see -1, so -1 will be to the right side of -1.3. Right. Similarly, 0.9, if there is some value -0.9, so that will be near to 0. So this is the rejection region. This is the rejection region, and this hole is the exception region. This is the exception region, and this is the rejection region. So if your value will be less than this value, let's say -2, so -2 will be less than this, you will be in the rejection region. Fine. So let us move onward and write down over here step 5. And step 5 is computations or calculations. Okay. Here you will substitute, first of all, you write down the formula. T is equal to x bar minus mu divided by s divided by square root n. This is basically your calculated z value, t value. So substitute the values. X bar is equal to the mean assembly time for a random sample of 24 cards using new method was 40.6 minutes with a standard deviation of 2.7 minutes. So 40.6 is your X bar. 40.6 minus what was mu? Mu was 42.3. Mu was 42.3. So please solve it if you have calculator with you. S was 2.7 divided by square root n, and n was 24. So solve this. First of all, 42.3 with
Sir,
negative sign plus
3.08
2.6
minus 3.0845.
minus
3.0845.
3.08. Okay, so,
45.
so are you sure?
Yes, sir.
Okay, minus 3.08 is the calculated value for z, for t. So here you will write down this value minus, sorry, write down here t calculated. Here write down t tabulated. So calculated value is minus 3.08 and tabulated value is that you have written over here in the distribution 1 minus 1.319, this value. So out of these two values, which one is greater? It was minus 3.084. Okay, or whatever value was there.
45.
4.5. So you may take it as 3.085, no problem. So now you have to see that out of these two, which value is larger? Which value is larger?
1.319.
Yes, of course, 1.319 is larger as compared to minus 3 because minus 3 will be far away from 0 as compared to minus 1.3. So this value is larger. It means this is the situation. And we have said that if calculated value will be less than, so you have written over here, if calculated value of t statistics will be less than minus this, we would reject H naught. So we have already given the uh, decision rule. So you can see over here, it is less than. The calculated value is less than the tabulated value. It means now you can say that we would reject H naught. So here you can write down according to the given decision rule. Uh, Let me write it down. As the calculated value of t statistic is less than the uh, tabulated value of t statistic, so we would we would reject H naught. Okay, so you will write down in this way, and then you will write down the next step, and that is step 6, interpretation. How will you interpret this? You will come again to the question and you will see the story. Can we conclude that the assembly time using the new method is faster? So you are going to reject the null hypothesis. It means you are accepting the alternate hypothesis. So exception of alternate hypothesis will mean that the assembly time using the new method takes lesser time, means less than 42.3 minutes. So as it takes lesser time, it means the new method is you can say is giving the ability to provide the cards to manufacture the cards more faster, you can say faster, more quickly. So here you can write down the same statement as yes, we can conclude that the assembly assembly time for cards on average, definitely on average, using new method is faster. Understand? So you have uh, given this interpretation, and it means that new method is good, okay, as it has reduced the time of assembling the card on average. Okay, so then there are a few more questions. Here, if you see in this case, the word more is there. So it is again single-tailed, and the alternate hypothesis will be written as mu is greater than the given average value. So average value is 50,000. So you may solve this question on your own. Then this is the question, and how will you solve this question? Definitely in this case, data are given, sample standard deviation and sample mean both are unknown. So you will find out these two using the given data. So if you confront with such question, you will first solve the question for x bar and s, and then you will decide that how will you construct the null and alternate hypothesis. And as I was saying that there is no question regarding the situation where there is equality sign is there. So no problem. I can explain the equality sign from the example that is there in your book. Where will you use the equality sign? So in the questions again, all questions are one-tailed. Simply remember that in the situations where you would use the equality sign in the null hypothesis and inequality sign like this in the alternate hypothesis, those would be the situations where the researcher will not be interested in knowing that which type of change has occurred. Either something has increased or it has decreased. Basically, he is simply interested that whether in fact some change has occurred or not. So as I have already explained in case of Z distribution, that if you see the word different or difference in the last statement like this, let's say this is the situation, and the statement is, instead of this statement, I am going to rephrase this statement as uh, can we conclude that the mean number of calls per salesperson per week is different from 40? So instead of more, if the word is there, is different from 40, then there will be two tails in the distribution. Okay. And you will write down the null and alternate hypothesis with equality sign and inequality sign. Okay. Similarly, in any case, whenever you see the word different or difference is there, so you will use equality sign and inequality sign. For details, you may see some examples that I have solved when I was solving questions from Z statistic, the previous section of your book in this chapter. Okay, so let us solve this question, and I may solve this question in both scenarios. I may solve this question for this case where the situation is less than, and I may also solve this question where the word difference is or different is there, so that you may be able to recognize that how would you tackle the situation when you confront with in the examination. So let us see this question and try solving this. Most air travelers now use e-tickets. Electronic ticketing allows passengers to not worry about a paper ticket, and it costs the airline companies less to handle than paper ticketing. It is of common sense. Uh, However, in recent times, the airlines have received complaints from passengers regarding their e-tickets, particularly when connecting flights and a change of airlines were involved. To investigate the problem, an independent watchdog agency contacted a random sample of 20 airports and collected information on the number of complaints the airport had with e-tickets for the month of March. The information is reported below. So what is this? These are the number of complaints. Okay, from 20 airports. At the zero point zero 0.05 significance level, can the watchdog agency conclude that the mean number of complaints per airport is less than 15 per month? What assumption is necessary before conducting a test of hypothesis? Plot the number of complaints per airport in a frequency distribution or dot plot. Is it reasonable to conclude that the population follows a normal distribution? Conduct a test of hypothesis and interpret the results. So we may answer one by one. So as far as the second part is concerned, plot the number of complaints per airport in frequency distribution. So this is definitely the question that you may solve, because you are able to write down the frequency distribution that you have already learned in the first course of statistics. And you may also you may also draw the dot plot, because you are familiar with these two, frequency distribution and dot plot. We have learned these two in the first course of statistics. So you may solve this second part. So therefore, I'm not going to touch this. What assumption is necessary before conducting a test of hypothesis? Definitely, the assumption will be the normality assumption. We will say that the distribution is normal, or you may say that these uh, you say complaints are normally distributed. So once they are normally distributed, only then you may draw such distribution. This is the normal distribution. So once you will draw the normal distribution, only then you will be able to say something about the null and alternate hypothesis. So this is the assumption. Conduct a test of hypothesis and interpret the results. So we can solve this question. Let us solve it. Again, step one, step two, step three, step four, step five. So I'm simply writing down over here one, two, three, four, five, six. Okay, to save my time. First step, null and alternate hypothesis. So in this case, H naught, H naught, and H1. What is H naught and what is H1? So for this, you have to see the question. Can the watchdog agency conclude the mean number of complaints per airport is less than 15 per month? Less than 15. So basically, this 15 is population mean because it is given. And the mean that you will find from data, that will be the sample mean, because you will find that mean from the sample data. So this mean is the population mean. Okay, so you will use this mean mu, and as the word less than is there, so you will first construct the alternate hypothesis, and you will write down the alternate hypothesis as this: mu 15, mu 15 less than, so you will put this less than sign over here, so automatically the null hypothesis will be greater than or equal to. Fine. And let us say the situation was like this. The question was, I'm rephrasing the question: can the watchdog agency conclude the mean number of complaints per airport is different? Instead of less, I'm saying is different from 15 per month. So if the word different is there, then you will write down the null and alternate hypothesis, where you will use the equality and inequality sign. So equality sign definitely will be in the null hypothesis, and inequality sign will be there in the alternate hypothesis. So uh, as you are familiar with these two, less than or greater than or equal to, and in case where more than situation is there, so better would be if I solve this question for the situation where I am not interested in knowing that whether the number of complaints on average is less than 15 per month, but in fact I am interested in knowing that whether the number of complaints are different from 15 per month. So I am rephrasing the question, and I shall solve it accordingly. So this is not less than, in fact, let's say it is different from 15 per month. So how would I construct the null and alternate hypothesis in that case? Okay. So you will solve it for the given situation, but I am rephrasing the question and I am going to solve it for the other situation that will help you in solving the questions that will be there uh, with the word different or difference in the required hypothesis. So this will be the situation. In fact, this is not point, this is 15. Fine. Let's say all else is same. So what is the level of significance? You will write down step 2. Step 2 is level of significance. Given it is point, what is this, 0.05. Then there comes step 3. And in step 3, you will write down the test statistic. Again, that formula, x bar minus mu divided by s divided by square root n. So you will leave it over here. You will come to step 4. You will draw the distribution, t distribution. Let us say this is the t distribution. Mean is 15. And see, as I'm solving this question for equality sign, so it will be two-tailed. One tail will be to the right side, one tail will be to the left side. So now you should be able to solve the situations where there are two tails in the distribution. So the given level of significance is 0.05. So alpha by 2 will be to this side. Alpha by 2 will be to this side. So this is 0.05 divided by 2. The answer is 0.025. And similarly, in this case, 0.05 divided by 2. The answer is 0.025. You can check this if you have calculator. If it is wrong, please correct me. Against 15, the value is 0. This is your t scale. This is your x bar scale. Okay. So now you would have two values, two tabulated values for t, against which you will decide that whether you will reject the null hypothesis or you would accept the null hypothesis. So let us find the two values. What is the sample size? The sample size is 20. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 multiplied by 2. 20 values are there. 20 airports are there. So 20 minus 1, 19. This is the degree of freedom, 19. And level of significance that you will see from single tail is 0.025. And if you are going to see this from two tail, you may see 0.05. The value will be same. Let us see. The degree of freedom, so you may see this value 0.025 from one tail, or so you can simply multiply this with 2 to have two tails, 0.05. So if you are considering straightforwardly without drawing the distribution, you may take this value. Otherwise, you will divide it with 2 to have single tail. So this is the value 0.025, or you may take this value. So against 19 degree of freedom, you will come down. This is the column, and which value is there? Yes, this is the value, 2.093. 2.093 is the value. This value you will write down 2.093. 2.093. 093 with positive sign, and to this side it will be with negative sign, 2.093. Fine. So now you know this area is the rejection region. This area is the rejection region, and this whole area, this area is the region where you will remain unable to reject the null hypothesis, or you may say that this is the exception region for simplicity. Okay, so now you have to calculate the value that will be called t calculated. So definitely if t calculated will exceed this value, that will be in rejection region, or otherwise it will be less than this value, then again it will be in the rejection region. So you may write down over here in decision rule, you may write down if the calculated value of t statistic will be more than 2.093, or it will be less than minus 2 point, it will be less than minus 2.093, we would reject H naught. So this is your decision rule. Fine. Then you will come to step 5. And definitely in step 5, now, first of all, you have to find out the required values that are not given basically in the question. So you will simply write down over here computations, and in computations you will again write down the formula. And in the formula you are required to find out x bar first. X bar is required. This is not given in the question, and s is also not given. So how will you find it out? Definitely x bar, you will simply sum summation x divided by n. This is the formula for this. And for standard deviation, you will use this formula, x minus x bar whole square divided by n minus 1, and square root is there. So you can manually find out these two values, but let me use Excel to find out these two values. Okay, so let me write down here x, and x values that I am looking from the other source: 14, 14, 16. You have, can you help me writing down these values quickly? 12, 12, 14, 13, 16, 15, 14, 12, 15, 15, 14, 13, 13, 12, 13, 10, and 13. So you can see these are in total 20. So how will you find out the average? Simply you will add and divide. So I can find it out using taking help of Excel. Average. Average of what? Average of these values. Enter. The value is 13 point. The value is 13.5. So on adding, you will have 13.5, adding and dividing by 20. Then I am interested in finding out S. So how will I find S? Here I will write down x minus x bar. X, let me write down x minus x bar. X minus x bar. So here I'm going to write it down as x, the first value, equal to this value minus the average value. Okay, so you write down in this way, and then you will put a dollar sign over here to fix the cell, so that every time this value is subtracted from the value that is for x. So now you will double click this value, and finally you will have x minus x bar. So definitely when you will add this value, you will have answer equal to 0. You may check this, that the sum of the dispersion from mean is always equal to 0. So equal to sum, sum for what? Sum for these values. That basically not required. These values are not required because the result is 0. So therefore, that is the reason that we take scare on this term, so that we avoid the situation where the result is 0. So sum of scare deviations. So for this, you have to write down this term again. Here you write down x minus x bar. This is closed, and then you will takes care of this. So simply put equal sign and have this value, and hat, and then write down 2, enter, and then come over here, double click or drag down. So this is the answer, and we are basically interested in the sum for this. So come over here, and so what is this? This is the sum of these sets. Fine. But we are interested in dividing this term with n minus 1. So what is n? And subtract that with minus 1. So n was, what was n? N was 20. N was 20. So write down this term, this figure, equal to this divided by 19. The answer is 2.263158. So you may take it up to 2.26. 2.26. So this value is 2.26. 2.26. So now these two values are there, and now you can substitute these values in the formula. The formula is x bar. What is x bar? We have found 13 point, sorry, 13.5. 13.5 minus what was the average? 15 mu. This was mu, divided by 2.26, we have just found, divided by square root n, means 20. So please give me the answer.
Minus 2.9682.
Minus 2, up to 2 decimal points, please. Point 2 point
2.96. 96.
2.9696.
Yes, sir.
So
968.
968. So you may round it off as
97.
2.9. Yes. So please round it off up to 2 decimal points. So 2.97 is the answer. So this is your calculated value. So definitely it is with negative sign. So you will come over here and you will see that what will be the situation when it is negative sign there. We would reject the null hypothesis if the calculated value will be less than this value. Okay, so please write down these two values, minus 2.97. This was the calculated value. You may write it down as t calculated, and here you can write down t tabulated or the critical value. So this value is minus 2.093. 2.093 with negative sign. So which one is larger out of these two?
93.
Calculated.
2.093 is larger. So you will draw, you will
9.
put this line, this sign. Okay. So what this means, the calculated value is less than the tabulated value. The calculated value is less than the tabulated value. It means that this less value will be in this region. 2.97 will be to the left side of this value, and it means that that will be in the rejection region. So what this means? This means that you would reject H naught. You would reject H naught. So you may write down over here, reject H naught. Reject H naught. So now in the final step, that is the step 6, what will you decide? What will you say regarding the null hypothesis? What that means? So as you are going to reject H naught, it means you are going to accept alternate hypothesis. And as I have rephrased the question was like this. There was no word less, there was the word difference. So you will simply write down in the interpretation that in the alternate in the as a result you will write down uh, based on the based on the empirical results, based on the empirical results, we would reject H naught, H naught that is how you will give that statement. That is What was the statement? The mean number of complaints, mean number of complaints per airport is, that is, here you write down, that is yes, yes. The mean number of complaints per airport is different from in per month. So in this way, you will represent, you will give the answer. And definitely, you when you will solve it according to the given situation that is given in your book, definitely the alternate hypothesis in that case will be different from this. As I have rephrased the question, I have made this question on my own. So this is the result. But when you will solve it for the original question, you will see that whether you are going to reject the null hypothesis or you are going to accept the null hypothesis. So you are suggested to solve this question on your own for the given situation. Fine. The other two very important things that I want to explain is are the decision regarding the null hypothesis based on two more things. One is probability value, and the other is, again, you may see, we may consider the absolute values. So in absolute terms, you may write down this in the fifth step as, so this is over. But two more things I want to explain over here, that you may take help of these two strategies to decide about the null hypothesis, whether you would have to reject this or accept this. So the first strategy is T calculated. Write down these, the T calculated in this way and T tabulated in this way. So these two bars are basically the bars that will give you the absolute value. So if some value is with negative sign, the value will become positive. Okay. So if you see in this particular case that we have just solved, the calculated value was minus 2.97, minus 2.97, and the tabulated value was minus 2.093, 2.093. So the rule is that if calculated value is in absolute terms greater than the tabulated value, we reject H naught. Okay, so the rule is if it is greater in absolute terms. So definitely when you will put these bars over here, these two values will become positive. So 2.97, this will equal 2.97, and this will become 2.093. Okay, so now you may see this will be the situation, greater than, greater than. So the rule is if calculated value is greater than the tabulated value, we reject H naught, we reject H naught, otherwise accept H naught. So reject H naught. So you may see we have rejected the null hypothesis using this strategy where there was no absolute values, and when you take it in absolute terms and you follow this rule, again you are going to reject H naught. Now finally, the last thing that I want to explain is regarding probability value. So p value, the rule is same as we have seen in case of z statistic. If p value is less than alpha, the level of significance, we reject H naught, we reject H naught. So this is very important because p value is normally seen when we decide something about the null hypothesis. Uh, Normally, the almost all softwares, in fact, all softwares give p value, the probability value, as a result, so that you may decide that whether you would reject the null hypothesis or you would accept the null hypothesis. So how will you find out the p value in this situation? So you will see basically the calculated value here. The calculated value is 2.97, 2.97. So you have to locate this value 2.97 against the degree of freedom. So degree of freedom in this particular case was n minus 1, and n was 20, n was 20. 20 minus 1. So 19 is the degree of freedom. So against 19 degree of freedom, you will locate the calculated value. You will locate the calculated value. So let us locate 2.97. This is the degree of freedom, 19 and 2.97. Let us see where is that. Where is that? 2.97. 2.97. See. 2.97. So 2.97 is not there, but we know that 2.97 will be in between this value and this value. It will be in between 2.8 and 3.5. Fine. 2 the calculated value that was 2.97 will be in between these two values, 2.861 and 3.579. So when you will use any software, exact probability will be there for you. But as we are doing things manually, so you will say that the probability value is in between these two values. Fine. So you will move upward and you will see that what is the probability value for the uh, you can say this value, that is the smaller value in this particular case. As compared out of these two, this is the smaller value, but when you will move upward and you will see these two levels of significances, this is the larger level of significance as compared to this level of significance. So you will take the larger level of significance. You can see that levels of significance are being increased when you will move leftward. Okay, and when you will move rightward from this position, the levels of significances are being reduced. So you will take the larger level of significance to avoid any confusion or any ambiguity about the rejection of null hypothesis. Basically, we want to improve the chances of rejection of the null hypothesis. Therefore, we will take the above side value. So in this particular case, the level of significance is 0.005 that we will take. So you may say that this is the p value. This is the p value, probability value that we have obtained against this value, 0.005. So in this particular case, you may straightforwardly see this value, or you may multiply this value with 2 if you are going to compare it with the level of significance, given level of significance that was 0.05. So let us see the situation. I can simply explain this. Uh, See, the probability value that we have found is probability value is equal to 0.005, and see that we have obtained this value from single tail, so from single tail as we obtain. So what alpha value you will take into your account? The alpha value will be the value that you have written over here in the single tail, that is 0.025. So you have to compare this with this value, not with this value. 0.025, 0.025, you will take this value, 0.025. So single tail. Okay, so which value is larger out of these two? 0.005, 0.025. This is your alpha value. This is your p value. Which one is larger out of these two? That definitely this value. 0.025 is larger than this. And the rule is, if p value is less than alpha, we would reject H naught. So here again, you will reject H naught. Reject H naught. Fine. Otherwise, this is fine. You may say that we have rejected null hypothesis based on this. But if you want to compare the probability value against the given level of significance, and the given level of significance was 0.05. So as it was two-tailed, so what will you do? Whatever you have found in form of probability value, you will multiply this with 2. Why? Because by multiplying with 2, you will have the same level of significance that is given in the question, as you have divided by 2 to have the single tail. So for two tails, you will multiply this figure with 2. So level of significance will be 0.05. So if you are going to take level of significance as 0.05, the given level of significance, and you are not considering the tails, you are saying that this is the level of significance. So far, with what value you will compare it? Definitely the probability value in that case, you would have to multiply that value with 2. So multiply this 0.005 with 2. So when you will multiply this with 2, you will have 0.01, this two tails. 0.01. So we'll take this value as your probability value. So both ways are correct. You may take any value. So if you are going to take this 0.05, so here the value will be 0.01. This is the probability value for two tail. So out of these two, which one is larger? Definitely alpha is larger. So using any strategy, you will have the same answer. The answer is, in this particular case, as probability value is less than alpha, reject H naught. So in all cases, using all strategies, the result is same. You are going to reject H naught. So this is all for today. Thank you very much for your patience. Meet you in the next class, inshallah. Wish you very good luck for the midterm examinations that will be there in upcoming week, inshallah. So before that, inshallah, we will cover one or two more topics.